In this mini lecture in Module 11, we're going to go over a chi-square test of the goodness of fit. The chi-square test of independence is what we did in the last mini lecture, and that examines whether two variables are related. So we can ask the question of if we have information on one of those variables, does that provide us with information on the other? So the example that we did previously was looking at exposure and seeing if that's related to actually having a disease. On the other hand, the chi-square goodness of fit test compares an observed frequency distribution with an expected frequency distribution that's based on a model. So it's based on some notion that we already have of how we expect that distribution to fall out. So our null hypothesis is that the observed frequencies are the same as expected from the model, and the alternative hypothesis is that the observed frequencies are not the same as the expected frequencies based on the model. Now we're going to go through a scenario to highlight this. The example we're going to go through is the data from a study of pain in cancer patients who experienced pain at some point during hospitalization, and then patients were asked to rate their current severity of pain according to the present pain intensity index, and we had 69 individuals who were involved with this study. There were 6 different ratings for pain. So a rating of 0 would be no pain, and then the ratings of 1 through 5 go through from mild pain up to excruciating pain. And individuals categorize themselves for their current severity of pain if they presented pain at some point during their hospitalization. This is the distribution of the pain rating. So we have ratings from 0 to 5, and of these 69 individuals, 34 of them presented with a pain rating of 0 or no pain, and then you can see how the rest of them fall out. So that's our observed data. When we think about where our expected values are going to come from, an oncology nurse believes that half of the cancer patients with pain at some point would have a current pain rating of 0, and the nurse also believed that 1/10 of the cancer patients would have each of the other pain ratings going from 1 to 5. So we can ask, are the data evidence for or against the beliefs of the nurse? So this is the model. So the model is that 50% of them would have no pain, and then 10% of the individuals would be in all of the other pain categories. That's where we get our expected values from. And notice that this is different from the chi-square test of independence in terms of where the expected values come from. So here they're coming from a model. So for the chi-square test of goodness of fit, step 1 is to look at our null and alternative hypotheses. These are the same ones that we just went over. Step 2 is to figure out our decision rule, which is 0.05, and step 3 is to collect the data and calculate the test statistic. So we have the data, so we have our ratings from 0 to 5, and the total number of individuals in the study were 69. So this is our observed data. And then we need to get our expected frequency based on the model. So the expected frequency for rating 0 would be that half of the 69 individuals would have a rating of 0, so it's 0.5 times 69 is 34.5. The model also predicts that each of the other ratings would be represented by 10% of the individuals in the study. 10% of the other individuals would be 6.9, and they should sum up to be the same as the observed. Now we can calculate the chi-square statistic. So we have our 6 different ratings because they go from 0 to 5. We have our observed values and our expected values. Then we can create a column where we have our observed minus our expected. So we're just going to subtract the expected from the observed. So some of them might be positive, some of them might be negative. That's fine. And then in the next column, we're going to take our values that we calculated for observed minus expected. We're going to square that, and then we're going to divide them by the expected value for their respective row. And that's what those values are. And then we're going to sum these up, because that's what our chi-square test wants us to do. So chi-square test statistic value is 26.391. Step 4, now we need to figure out our degrees of freedom. So our degrees of freedom are k minus 1, so it's the number of categories that we have minus 1. So we have 6 different categories of pain. So it's 6 minus 1 gives us 5 degrees of freedom. You can look this value up in Table E to figure out the critical value. Remember that small values of chi-square will support our null hypothesis, because that means our observed values and our expected values will be very similar to one another. And a large value means that our expected and our observed are very different, so that would not support our null hypothesis. Our critical value is 11.070, and our chi-square statistic is 26.391. This is greater than our critical value, therefore we reject our null hypothesis, and our data do not fit the model that was suggested. So our p-value here associated with this, when you look at the table, is less than 0.001. So the data are not fitting the model. When we actually look at the data, so we have the observed frequencies. I just calculated that in the observed frequency column. So we have the number of individuals divided by 69 to actually get the proportion. And then we have the expected frequencies based on the model on the column on the right. And you can see, looking at this, that for the rating of 0, the prediction from the nurse was that about half of the patients would have no pain, and that seemed to be about right. Also, for the rating of 3, that was really close. The observed was 0.09, and the expected was 0.10. But you can see that for some of the other categories, it was considerably off. So for pain ratings of 4 and 5, the observed and expected were quite different, again for 1 and 2 as well. And so because some of these are quite different, that's going to make our calculated chi-square value quite large, and that's going to lead to us rejecting the overall null hypothesis because the model is not fitting well enough for it to be accepted. So that is the chi-square test for goodness of fit.